finally, to this example, we must show that f is not open. To show that f is not open. When you show that any examples is open, so you need like a closed open a closed function in the above cases, we take it a closed set in general. We say that h equal to AB, but when you show that f is not open or any others f is not closed, maybe you need give an examples, and these examples by the definition of that one asked you. When you say that f is open set, so the image of every open set in X must be open in Y. But when asked you show that f is not open, so what you need? You need to give an example in a domain that is open, but when you work it on it by giving a function f on it, and then you must give a set that is not open. So for this one, we need give an example. Or we say that we see that -1 to 1 is an open set in X, means in a domain in R. And now we show that f of -1 to 1 is not open to Y. To show f of -1 to 1 is not open in Y, which is equals R also. So to find it, f of -1 to 1 equals to, by the definition, all f of x belongs to R. This R is codomain. Belongs to R such that x belongs to -1 to 1, where x belongs to -1 to 1. And then it is equals to f of x belongs to R such that -1 lead them to x, and which is lead them to 1, and we want to find the f of x. So this one is divided into two parts. One, because you have 0 in here, -1 in here, and 1 in here. When you say that x belongs to -1 to 1, so x may be in here or maybe in here. So it's divided into two parts. Implies that f of -1 to 1 equals to f of x belongs to R such that -1 lead them to x, which is lead them to 0, or 0 leads them or equal to x, which is lead them to 1. And we write in these two parts like that, equals to f of x belongs to R such that -1 lead them to x, which is lead them to 0, union f of x belongs to R such that 0 leads them or equal to x, which is lead them to 1. And for all two parts, we need to find f of x, and f of x, you know that, is equal to x squared. So we squared both sides or all sides into two equalities, we get f of x belongs to R such that for this one we get 0 less than to x squared, and which is less than to 1, union for the last one f of x belongs to R such that 0 less than or equal to x squared, which is less than to 1. And this one gives us, which is equal to 0 to 1 union, and the other ones gives us the closed 0 open one, and the finally gets 0 to 1, and we see that which is not open, So f of minus 1 to 1, where m minus 1 to 1 is open, is not open. So mean that f is not open function, because if f is open function, so needs or must be the f of all open sets in the domain is open in a codomain. But for one example, we showed that f is not open. So this is a solution of that example. Thank you for watching.